Hi guys, and welcome to Computer Networking 101. This is lesson 1 of our series, and in this video series, we're going to cover the terminology, concepts, and the different types of equipment you're going to need when working within computer networking. After completing this series, you'll have the foundation needed to design, configure, to support, and to troubleshoot data networks. This first lesson is simply going to be a high-level overview of some basic concepts and terminology. So, why is networking important? Why should we learn any of this or spend our time? Now, there may be a vast array of correct answers to this particular question, but I'm simply going to give 2 reasons. The first being shared resources, and the second, communication between networking devices. So, shared resources. What are we talking about here? Well, to go over a couple examples of what would fall into this category, we could look at network printers or shared drives as network storage. Even internet access would be considered a shared resource for a network. And there's many more beyond that, but just for a quick list to get you really on the same page. Now let's talk about communication. For devices to share those resources we just listed, they have to be able to communicate with one another, and they have to be able to communicate with the resources that we want to share. So what do we need to allow this communication? Well, the most obvious thing would be a path to send the information between the devices. Typically, this is handled via a hardline connection or something using radio waves, maybe Wi-Fi. But even if we get the information to that other device, we're still going to need a predetermined way to send it so that when it does reach the other end, it can be understood. Let's do a human example here. If you wanted to talk to another person in, let's say, a far-off country, you'd need a way for your message to reach that person. Maybe you'd make a phone call or something as old-fashioned as sending a letter. But even if your message did reach them, you both would still need to be able to understand what the other person is saying. In a nutshell, you'd need to be able to speak the same language. So let's talk about communication channels. Communication channels are the physical means to send and receive information. The 2 most common forms in networks today are transmission over wire, typically Ethernet, and transmission using radio waves, also known as Wi-Fi. But like we said before, just getting the information there isn't going to be enough. The recipient of the information has to be able to decipher it to really get the point, to understand what the sender is trying to get across. So that brings us to protocols. A protocol can be defined as the rules governing the syntax, semantics, and synchronization of communication. To put this a little more plainly, protocols provide a predefined procedure to organize the information that we want to send between these network devices. This can be compared to speaking the same language from our human example. Now, how do we classify computer networks? There's actually quite a few different ways, but a couple here real quick. We classify them based upon the scope, their geographical scope. Is this network spanning a building? Is it spanning a city? Is it spanning a country? We can also classify networks based upon the topology. And very shortly here, we'll discuss a little bit more about what topology is and what that means. Another way would be ownership. Is this a government backbone? Is this a bridge between 2 corporate sites? But let's talk about that geographic spread or scope. A couple different ways this is divided out, but 3 of the most common would be local area networks, which would be kind of what it says, It's local. It's in the same building. Sometimes even it's the same room you're in, depending on the scope of the building and how things are laid out. A little bit bigger than a local area network would be a metropolitan area network. This would span multiple buildings within a city, or perhaps even if it's a government thing, the city as a whole. Last and the largest would be wide area networks. Things like the internet and intranets for international companies would fall into this category. Now, I said we'd talk about topology. Let's start off by defining it. A network topology is the way a network is arranged, including the physical or logical description of how links and nodes are set up to relate to each other. And that sounds like a mess of words, so let's give a little bit of a summary here. A topology can be defined by how devices are physically connected, meaning the type of connection channels, or communication channels, as well as the layout of those channels, and also the logical aspect of how the data is transmitted. Now, I know we went over a bunch of stuff here today, and we did it in a pretty short amount of time, under 10 minutes. So let's review all the different concepts and terminology we've went over. A network is the interconnection of computing devices with the intent to share resources and to communicate with each other. Basically, the network device is communicating. For devices to communicate, they have to be able to speak the same language. And there must be a physical way for that information to be exchanged. The communication channel can be a cable or a wireless signal. And don't forget about network protocols. They describe how the data we send is organized for transmission, and then how it can be read when we receive it. And last, a topology tells us about the physical and logical configuration of the network, as well as the network's geographic scope. So guys, that's all we have for lesson 1. I'll see you guys in lesson 2. Thank you for joining me.